To my video on orbitals and AS level chemistry. So to understand what orbitals are, we need to know what an atom is. So an atom consists of a nucleus, which is shown as this black dot here, and what's in the nucleus are the protons and the neutrons. The protons have a positive charge, the neutrons have no charge, and because like charges repel each other, the neutrons are in the nucleus to stop or to reduce the repulsion between the protons. And surrounding this nucleus are the electrons. These are much smaller, but they have a negative charge. So these are attracted to the positive charge of the nucleus. So from GCSE, you'll probably know that electrons surround the nucleus in things called shells. And each shell can hold 8 electrons, apart from the central shell here, which can hold 2 electrons. So that can hold 8 and that can hold 2 electrons. But for AS chemistry and A2 chemistry, you need to understand that shells are not, we don't really talk about shells much anymore. Instead, we talk about these things called orbitals. So, orbitals are similar to shells, but they're just a more precise way of understanding how electrons exist around an atom. So, orbitals are areas around the nucleus where there's a high probability of finding electrons. Now, in each orbital, there can only be 2 electrons, so 2 electrons in each orbital. Now, because electrons have the same charge, they're negatively charged, in order for there to be 2 electrons in an orbital, there needs to be opposite spin. So one is spinning clockwise, like this, so that's clockwise, and one is spinning anti-clockwise. So this spin means that these electrons can exist within the orbital together. Now, so we scratch this sort of idea of the shells here. Now, so you may come across shells, but orbitals is what you need to be thinking about. So there are 4 types of orbitals, and there are 3 you really need to know about for AS chemistry. And these include the S orbital, which is just round, but remember, it's an orbital, it's not a shell. So this is the S orbital, and this line here is where there's a high probability of finding an electron. So it's just spherical here. And so this is S equals S, an orbital. There's the P orbital, but there's 3 P orbitals. So it's often called sort of a P subshell. So there's one like this, one like this, and one like this. And they've all, so there's 3 P orbitals. So this means that in the P subshell, because each one of these can hold 2 electrons, there's actually 6 electrons in the P subshell. But there's still 2 electrons in the P orbital. And there's the D orbital, which can hold 2 electrons, but because the D subshell has 5 orbitals, sorry, there are 10 electrons within the D subshell. But how do these orbitals arrange themselves around the nucleus here? Well, that's what we're going to discuss now. These orbitals don't arrange themselves randomly. They are organised properly around the nucleus. So say let's take the atom carbon. So you know carbon has 6 electrons because its relative atomic number is 6 and its relative atomic mass is 12. So that we put 6 and 12 there. So this tells us how many electrons are, because there's the same number of electrons as there are protons in a neutral atom. So it's got 6 electrons. So I'm going to write out the electron configuration of carbon. So first you fill the S. So we call this, because it's the closest to the nucleus, it's called 1, and you put 2 signifies how many electrons there are in the in this orbital. Then it goes 2s2. So far we got 4 electrons. Now the interesting thing here is it goes to P. And remember we said there were 3 P orbitals. So we call them X, P, Y, P, Z. And you put 2 in front because this 2 tells us what energy level they're at. But there are only 2 electrons left to fill. So common sort of thinking would be that 2 electrons would go here, and then they would leave these 2 orbitals empty. But in actual fact, within this subshell here, so this is a subshell, you fill each orbital once before you make the pair. So it would be 1, 1. And this is the electron configuration of carbon. So let's do another atom. Let's do oxygen. So we know oxygen has a relative atomic number of 8, relative atomic mass of 16. So this is the number of electrons it has. So again, we fill 1 S2, 2 S2. And again we have 3 p orbitals, so 2p x. So you fill 1. So how many more electrons do we need? So we've got 4 here. We need another 4 to fill it up. So let's draw this first of all before we fill how many electrons there are. So we need 2 in here, 1 in here, 1 in here. Because how it's filling is it's going 1, 1, 1, and it's filling this one, and that equals 4. So we count 2, 4, 6, 8. And that's how many electrons there are in oxygen. Now I'm going to give you some examples, and I want you to sort of do them in your head, and I'll answer them for you later. So let's do a simple one, which will just be hydrogen. Get started. So do hydrogen, and we'll come back to it. Welcome back. So if you've done that, then we should know that hydrogen has 1 electron. It has 1 electron, and because it has so it's just simply going to be 1s1. So hopefully you got that. The next atom you can do, or element, is sodium. So it has that. So it has 11 electrons. So I'll let you do that. Pause the video and come back. So it has 11 electrons. So like usual, we're going to start off with S. That's 2. 4. Be careful here. How many electrons can we have in the p subshell? 6. So if we do that, that would be, so we can fill each p orbital, because that would still only make 10. So 2, 2, 2. So 2, 4, 6, 8, 10. And let's go down here. So what's going to happen now? Well, it's going to go 3s1. Do one more example, a bit more complicated. So let's do calcium, which is going to have 20 and 40. So pause the video and come back if you can do that. So calcium has 20 electrons. We know that from there. And let's just start off. So it's going to be 1s2. 2s2, so we've got 4 electrons so far. Be careful again with the p subshell. So just write them out first before you fill them out. So you don't have to put X, Y, Z, but it does sometimes help. So if we have 6 here too, that's going to make 10, so we can just fill these out. I'm going down here, so just carry on from below. So far we've got 10 electrons, so what we're going to do now, we're going to go back to the S, 2, so we got 12 so far. We go 3p again, so it's going to go 3p, so how many electrons do we have so far? 2, 4, 6, 8, 10, 12. How many electrons do we need? Well, we need 8, so we can again fill up all the p orbitals. So that's 2, 2, 2, x, y, z. Now, usually have a 3d orbital, but an interesting fact that you need to know is that the 4s orbital fills before the 3d orbital. That's you need to know that, or subshell, sorry. So in actual fact it will be 4s2. So there we got 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So that equals 20. This is the important thing. Don't forget this fact. You need to know this. That the 4s orbital fills before the 3d orbital. And from there on you should be able to do any any of the ones in the exam you'll be required, because they don't go beyond this, but they will expect you to know this fact. The 4s orbital fills before the 3d orbital. So thanks for watching, and in the next video I'll discuss more about sort of ionization energies and sort of basic AS chemistry. Thanks for watching. Cheers.